Alright, so in this video, I'm going to solve the equation 8 to the power of x is equal to 32. So, to solve this, I'm going to start by taking the log on both sides. So I get log of 8 to the power of x is equal to log of 32. And now if I have something in the form log of a to the power of b, I can move this exponent and b to the front of the logarithm. So this is turned into b times log a. So log a to the power of b is equal to b times log a. So now in the case of log 8 to the power of x, we can think of x as b, so we can move x to the front of the logarithm. So I get x times log of 8 is equal to log of 32. Now, from here, I'm going to divide both sides by log 8 because we want to isolate x because that's what we're trying to find the value of. So now these two cancel out, and I get x is equal to log of 32 over log of 8. Now, log of 32 is the same thing as log of 8 times 4. So I get log of 8 times 4 over log of 32. And if I have something in the form log of a times b, this is equal to log a plus log b. So in this case, this is going to equal log of 8 plus log of 4, and I have this over log of 32. Sorry, I have this over log of 8. Now, this turns into log 8 over log 8 plus log 4 over log 8. So now these two cancel out to get 1. So I get x is equal to 1 plus log of 4 over log of 8. Now, log of 4 is the same thing as log of 2 squared. And log of 8 is the same thing as log of 2 to the power of 3. So now if I have something in the form log of a to the power of b, again, I can move b to the front, so it's b times log a. So that's exactly what I'm going to do with both of these. So I get x is equal to 1 plus, I can move the 2 to the front. So 2 times log 2 over the same thing with 3, so 3 times log 2. So now these two cancel out, and I get x is equal to 1 plus 2 over 3, which is equal to 1 is the same thing as 3 over 3, so 3 over 3 plus 2 over 3, which is 5 over 3. So x is 5 over 3. Now, how do we know that this is the right answer? So, going back, we have a to the power of x equals 32. And we're plugging in 5 over 3. So we get 8 to the power of 5 over 3 is equal to 32. Now, if you already know, 8 is the same thing as 2 to the power of 3. So I get 2 to the power of 3 to the power of 5 over 3 is equal to 33 is the same thing. 32 is the same thing as 2 to the power of 5. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So these two 3's cancel out, and I get 2 to the power 5 is equal to 2 to the power 5, or this is the same thing as 32 is equal to 32. This is right. Now, I also have a second method of solving this problem. So for the second method, we have the same equation, a to the power of x is equal to 32, and this is a simpler method. So for this method, I'm actually just going to start by rewriting these two numbers. So 8, I'm going to rewrite as 2 to the power of 3, and 32, I'm going to rewrite as 2 to the power of 5. So I'm rewriting both of these as the same bases, which now it makes them much easier to solve. 2 to the power of 3 to the power of x is the same thing as 2 to the power of 3x, which is equal to 2 to the power of 5. And because these two have the same bases, a to the power of m is equal to a to the power of n, meaning m is equal to n. So 3x is equal to 5, and x is equal to 5 over 3. So that's another method of solving this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends or family. Thank you. All right, so in this problem, I have 2 to the power of 19 minus 2 to the power of 18. So for my solution, first start with 2 to the power of 19 minus 2 to the power of 18. Now, 2 to the power of 19, this is the same thing as 2 to the power of 18 plus 1. So now I have 2 to the power of 18 plus 1 minus 2 to the power of 18. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 18 plus 1, that's going to equal 2 to the power of 18 times 2 to the power of 1. And I have minus 2 to the power of 18 at the end. Now from here, I can go ahead and factor out 2 to the power of 18. So I have 2 to the power of 18 times 2 to the power of 1 minus 1. Now 2 to the power of 1, that's simply equal to 2. So I have 2 to the power of 18 times 2 minus 1. And 2 minus 1, that's equal to 1. So now I have 2 to the power of 18 times 1. Now 2 to the power of 18 times 1 is simply just 2 to the power of 18. So I'm simply left with 2 to the power of 18. Now, although this is a solution, I'm actually going to find a way to simplify this. So 2 to the power of 18, this is the same thing as 2 to the power of 9 times 2. And if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So 2 to the power of 9 times 2, that's going to be 2 to the power of 9 to the power of 2. Now 2 to the power of 9, this is equal to 512, so I have 512 to the power of 2. 512, I'm going to rewrite this as 500 plus 12 to the power of 2. Now this is the same thing as 500 plus 12 times 500 plus 12. So to solve this, I'm going to first start by distributing the 500. So now I have 500 times 500 plus 12 times 500. Now if I distribute the 12, I have plus 12 times 500 plus 12 times 12. Now 500 times 500, that's going to be 250,000. Plus 12 times 500, that's going to be 6,000. Plus again 6,000. Plus 144. Now 6,000 plus 6,000 is 12,000. And 12,000 plus 250,000 is 262,000. Plus 144 is 262,144. So this is my answer. Alright guys, so in this equation, I have 2 to the power of m minus 2 to the power of n is equal to 8,064. So I want to find the value of m and n. So
Because 2 to the power of m minus 2 to the power of n, because this is positive, we know that 2 to the power of m is greater than 2 to the power of n, meaning that m is greater than n, because both of these are the same bases. So I'm going to let m equal to n plus k, and k is an integer. So if m equals n plus k, then I have 2 to the power of n plus k minus 2 to the power of n is equal to 8064. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of n plus k, that's going to equal 2 to the power of n times 2 to the power of k minus 2 to the power of n is equal to 8064. Now, if I factor out 2 to the power of n, I get 2 to the power of n times 2 to the power of k minus 1 is equal to 8064. And 8064, this is simply equal to 128 times 63. So I have 2 to the power of n times 2 to the power of k minus 1 is equal to 128 times 63. Now notice I have 2 to the power of n, that's going to be an even number, and 2 to the power of k minus 1, that's going to be an odd number, because 2 to the power of k is going to be even, and an even number minus 1 is going to be odd. And 128, this is even, and 63, this is odd. So now, meaning I can simply set the evens equal to each other, and I can set the odds equal to each other. So 2 to the power of n, this is equal to 128. So let's first go ahead and solve this. If 2 to the power of n is equal to 128, well, 128, that's the same thing as 2 to the power of 7. So I have 2 to the power of n equal to 2 to the power of 7, and this means that n is equal to 7. Now, we have 2 to the power of k minus 1 equals 63. So if 2 to the power of k minus 1, if 2 to the power of k minus 1 is equal to 63, then all I have to do is simply add 1 on both sides. These two cancel out, and I'm left with 2 to the power of k is equal to 64. Now 64, that's the same thing as 2 to the power of 6. So if 2 to the power of k is equal to 2 to the power of 6, meaning k is equal to 6. So now remember how we said m is equal to n plus k. So in this case, n is 7 and k is 6, so m is equal to 6 plus 7, which is 13. So m is equal to 13, and n is equal to 7. So these are my solutions. Alright, so in this problem, I have 100 to the power of 100 over 50 to the power of 50. So 100 is the same thing as 50 plus 50. So I'm going to rewrite this as 100 to the power of 50 plus 50. And I have this over 50 to the power of 50. So now, an important property of exponents is that if I have something in the form a to the power of m plus n, this is simply equal to a to the power of m times a to the power of n. So as you see, in this case, I have 100 to the power of 50 plus 50. So 100 to the power of 50 plus 50, this is going to equal a to the power of m, so 100 to the power of 50 times a to the power of n. And n is the same thing as m, so again, 100 to the power of 50. So now I have 100 to the power of 50 times 100 to the power of 50 over 50 to the power of 50. Now, if I have something in the form a to the power of m over a to the power of, over b to the power of m, this is equal to a over b to the power of m. So in this case, I can rewrite this as 100 to the power of 50 times 100 over 100 to the power of 50 over 50 to the power of 50. And now I'm going to rewrite 100 to the power of 50 over 50 to the power of 50 as 100 over 50 to the power of 50. So now 100 divided by 50 is simply 2. So now I have 100 to the power of 50 times 2 to the power of 50. Now, if I have something in the form a to the power of m times b to the power of m, this is simply equal to a times b to the power of m. So in this case, I have 100 to the power of 50 times 2 to the power of 50. We can think of a as 100, b as 2, and m as 50. So this is going to equal 100 times 2 to the power of 50. Well, 100 times 2 is simply 200, so I'm left with 200 to the power of 50. So this is my answer.